This one says write each expression as a single logarithm. So again, anytime on our formulas, anything that's on the left-hand side of those formulas, that's considered simplified form. The right-hand side is called the expanded form. So in the simplified form, you just have a single logarithm. So our job here is to simplify again, and sometimes we have more than one log law. So in the first one, you see that you have log x plus 3 log y. And the first thing that you probably notice is the adding. And you want to combine them because we have a rule for adding that says if I have a log plus a log, it's multiplying inside. But we have to be careful because if we look at the log law up over here on the wall, it only works when it's 1 log plus 1 log. And we have a 3 in front. So we can't use the log law for adding as multiplying unless it's just log plus log and the bases are the same. And right now we have log plus 3 log. So we need to get rid of that 3. We can do that because we have another log law that says if you have a number out in front and you're multiplying, that number can become an exponent inside the logarithm. So I can change the 3 log y to log y cubed. And now I have log plus log, so I can just write this as multiplied together log xy cubed. In part B, again, we have log, well, plus 2 log minus 4 log. Those numbers in front can't be there to use any of our log laws. And so what I'm going to do as a first step is I'm going to say, well, that 2 can go in as an exponent, so it becomes y squared. And that 4 can go in as an exponent to become z to the 4. Now, a log plus a log, the first two, I could combine. Because adding is multiplying, so I could get log y squared, and then I still have minus log z to the 4. And we have another log law that says a log minus a log is subtracting. I mean, subtracting is dividing inside your logarithm. So I can now combine all of this as a single logarithm. Now what we're going to find, and what I'm going to get you to do, is eventually I'm going to get you just to go from that step to that step all at once. And we're going to do another example in between to help us see what we can do to do this in one step. It's not bad that you did it in 2 steps, but if we wanted to do this in 1 step, like if I had this question in between B and C, B.5, okay? If I had log of A plus log of B minus log of C plus log of D minus log E minus log F, wow. And I wanted to combine that to be a single logarithm. You could do them first 2, done. Then the next one's done. Then the next one's done. Then the next one's done. And you could do that all the way along. But I want you to get comfortable with going right from there and see if you can figure out what I'm doing as a shortcut. Done. How did I know which ones to put in the numerator, which ones to put in the denominator? The negative ones are in the denominator. Because every time you're subtracting, you're dividing. So every negative 1 would end up in your denominator. Every time you're adding, you're multiplying. So those would all end up in your numerator. And that allows you to go a lot quicker from one step to the next. In fact, sometimes students make mistakes because they would add those ones together and then keep the negative. Oh, it just sometimes gets a little bit messy with the negative signs. So if you do this all at once, it does make your life a lot easier. And then part C, we had, oh, this one's a little bit tricky. We need to have it as a single logarithm, and we have log 2 of 6 minus 3. Whew. Those aren't both logarithms. We only have rules if we have log plus log or log minus log or number multiplied by log. But now, right now, I have log 2 of 6 minus a number. The only way I can combine with subtracting is if I'm subtracting with the same base. So I somehow would need to put a number in here so that this is equal to this. What number goes in that circle? 8. Why? Remember, logs solve for exponents. So when I write log 2 of 8, really what I'm doing is saying to myself, 2 to what exponent is 8? And you know that 2 cubed is 8, so log 2 of 8 is equal to 3. And if they're equal, then log 2 of 6 minus 3 is the same as log 2 of 6 minus log 2 of 8. And now I'm subtracting with the same base. So I can divide. If I wanted to, I could simplify to log 2 of 3 over 4. Okay, try those questions.